Problem 26, solve for n. A little cramped in there, sorry about that. So all we're going to do, we're going to distribute the 4 through to each of these pieces, and then it equals all that together. So 4 times n is 4n. 4 times 1 is minus 4. Over here, I have 2n plus 5 plus that. Well, 2n and 2n is 4n plus 5. Now, at this point, I'm like, hey, 4n minus 4 is going to equal 4n plus a 5? I don't think that's possible that you can take 4 away and get the same answers when you add 5. But something tells me something's not right here. But when I continue to work it, I move my 4n over to get all variables on the same side. And I notice right then, oh my gosh, they all disappear. I end up with this statement of negative 4 equals positive 5. How often does that happen? Is that ever true? Is negative 4 degrees ever equal to a positive 5 degrees? That's never true. It never happens. That means there's no solution to this problem. There is nothing that you could plug in for n that will ever make this true. This is one of those special situations where either nobody works or everybody works. If you end up with a false statement like this, nobody works. If you end up with a true statement like 5 equals 5, that always is true. That means everybody would work. So problem 26 is either going to be nobody works, no solution, something false like this, or something's true, and that means infinite number of solutions. Everybody works. Next problem, 27, solve for n. Well, I need n by itself, so I need to move that 9 over. So I subtract 9. That goes away. I get the opposite of n is equal to a w minus 9. Now it says the opposite of n is equal to w minus 9. Now remember, if I said the opposite of Tom is handsome, what does that mean Tom is? Well, he's ugly, right? The opposite of Tom's handsome, that means Tom himself must be ugly. So if we have the opposite of n is equal to a w minus 9, that means n itself must be the opposite of each of these pieces. W must be negative, and that subtract 9 must be a positive 9. So the answer to 27 for this lookalike problem is n equals the opposite of w plus 9. Please know we could rewrite that as 9 minus w, because here in the problem 9 is positive. It's positive right here. And then w in the problem is negative, and that has it negative right there. So 9 minus w would be another way we could write it if we wanted. And the final problem, solve for n. Well, n's right here. I need to move my 5 over. So I'm going to move my 5 over. I'm going to add 5 to both sides. Goes away here. Here's n. 3 plus 5, 8. But notice all these have n first. Well, it just wants you to rewrite this. So here's n. Here's 8. Alligator in the problem is like this. It's eating the n. So I need to make sure it continues to eat the n. So this is what I'm looking for. This and this are the same thing. There is no difference. It's just the n is coming first, then the 8. Notice that the n is being eaten in both pieces. So I'm looking for n is greater than 8. Choice A for this lookalike problem number 28.